Today we'll be speaking about the art and science of neuroplasticity, how self-reflection and discipline cultivate neural integration. So for this topic, we'll be focusing deeply on a very exciting area of science, and that is the area called neuroplasticity. And to begin with, let's just talk about that word, neuroplasticity. Some people like to make it one word, neuroplasticity, all in one continuous set of letters. Other people like to write it as two words, neural, A-L after N-E-U-R, neural, and then another word, plasticity. They mean exactly the same thing. So don't worry if you see it in some publications one way and some publications another. Neuroplasticity basically means this. How does the nervous system, that's the neural part, become shaped by experience? That's the plastic part. Now, for those of you who don't remember the original use of the word plastic, it means moldable, how you can actually change something. So I know we have hard plastics that seem like you can't change them, and so we can get confused by that term. But plasticity really means how is something moldable, in this case, by experience. So the nervous system, which includes, of course, the collection of neurons up in our head, our brain, but also includes clusters of neurons distributed throughout the whole body. So, for example, around the heart and around the intestines. They go way out to the extremities. So our nervous system is actually moldable by experience. So we call that neuroplasticity. And when we talk about how experiences shape us, to really understand that, how do we learn from experience? How do we, for example, use our own minds to focus inwardly with reflection to create, in terms of self-reflection, some altered state of firing in the moment, and how does that firing change to become change in structure? And we'll talk about that. So that's self-reflection. And then we have this idea of teaching, which from a parenting point of view can be thought of as what discipline really means. So the word discipline has sometimes been, I think, misused as punishment, and in modern culture people have mistaken discipline for let me punish you, give you a consequence to your inappropriate action, child. But instead, discipline really means to teach, and being a disciple means to be a student, not a prisoner. So in discipline, that is in the interactions between adults, such as parents or other caregivers, teachers as well, and the student, which could be the child or the pupil or a child on a team taught by a coach, this experience of being taught is actually what discipline is all about. So you can have discipline also harnessing the power of neuroplasticity. So that's what we'll be covering, is how these two very important sources, one interpersonal, one intrapersonal, how do they actually shape the structure of the nervous system, and how can we cultivate something called neural integration, something we've talked about in many of our other journals in a large, broad point of view for the world, for our culture, for families, for relationships, for our inner life. And now we're going to look at the deep way in which neuroplasticity can serve to promote neural integration and what that really means. So come join me, and we'll begin right now. The art and science of neuroplasticity. What do we mean by that? Well, the art notion of this title means that there is a way of very creatively approaching the processes by which our nervous system will become changed by experience. So that we say, as Louis Pasteur said, chance favors the prepared mind. So in science, what we mean by that is if you prepare your mind to understand neuroplasticity, you'll be able to optimize how you can have your nervous system grow in response to both inner and interpersonal experience. So the art is the idea of how do we prepare our minds so that we can creatively take full advantage of moments of inner reflection and interpersonal experience to promote optimal learning. What's the science of neuroplasticity? Well, of course, that word science means what's the objective way in which we have carried out experiments or observations systematically to ascertain the fundamental basis of the field we're talking about. And in this case, it's the field of neuroplasticity. So we'll be looking at both the art, the creative applications, and the science, the actual research, that informs us, prepares our minds about how to optimize neuroplasticity. So let's begin with the science so we can understand then how to creatively apply the science in our daily lives to be the art of neuroplasticity. So what is the science of neuroplasticity? Well, one of the first places to turn to is the study of memory. So we can see, in fact, how when you study the neural bases of memory, you can see how an experience at time 1 alters the way the nervous system is functioning, to then change at time 2 the way that nervous system is capable of functioning. That can be called encoding of memory. Then, when you have the changes in the nervous system, whether they're temporary or more long-term, we call that storage. Finally, you have what's called retrieval, which is the activation of some elements of the neural firing that are related to the initial encoding, how they were then stored, and then how do they get reactivated. So that's what retrieval means. So we're going to look at the science of encoding, storage, and retrieval when we study the notion of memory and try to understand how that is one aspect of the science of neuroplasticity. In addition to memory studies, we also want to look at primary neural studies, the neuroscience of how neurons function, how do they actually link up to each other, and what's the molecular basis of some of the changes that happen in the brain. So we need to study that as well. A third area that we'll need to get into, as we'll see very soon, is the area of genetics and epigenetics, because we'll soon learn that the way the nervous system changes in response to experience for long-term changes requires the activation of genes. So we'll have to understand genetic information encoded in our chromosomes, and we're going to need to understand how there are control mechanisms that sit on top of the genes called epigenetic regulators, and how those, in fact, not only control how experience will activate genes to allow proteins ultimately to be produced and then structure to be created anew because of an experience, the basis of neuroplasticity, but we're going to also see, amazingly, that experience not only activates genes, but it changes the epigenetic regulators that it's dependent upon in order to activate genes in the future. So yes, it gets very feedbacky, because you're going to actually be changing the very molecules that regulate the ability to change in response to experience. And that's where it gets incredibly exciting and also subtle, that we have to understand changes are not only in neural architecture, but they're in epigenetic control. So we'll need to look at that. And then finally, we're going to look at the actual process of neuroplasticity from the larger point of view of how does the connection of you as an individual with a nervous system engaging with the world actually influence how your brain will change. And we're going to see that to really understand that, we're going to need to look at two systems. The system of attention, that process which regulates energy and information flow, and we're going to look at the emotional systems of the brain that overlap directly with the social systems. So the social and emotional features of our brains very much connect us with the experiences we're having in a learning environment. So those are the main things that we're going to cover in the diving deeply into the science of neuroplasticity. So let's begin not with memory, but we'll begin with the neuroscience of neuroplasticity. So what does it mean to have an experience and then to have it change neural structure, the essence of neuroplasticity? What does that really mean? And if you've been with me on this journey of digital journals or in other times, you know I'm kind of a nut for defining terms and really making sure that you and I are together on what these things actually mean. And one of the frustrations I often feel if I'm reading things in, let's say, the newspaper or just magazines or even sometimes in books, is that there isn't a clear definition of the terms that are used, and so it really depends on the reader's own connotation of what that word means and the hope that they get what the writer is actually trying to say. So she means this or he means that. But if it isn't clearly defined, there can be a mismatch. So my concern is for you to know what I mean by the words I'm using, because after all, this experience you and I are having right now is actually an example, isn't it, of neuroplasticity. That if this digital journal is going to work well, it's going to have to involve a process by which the experience you're having diving into the digital journal is actually changing you in a way that will be positive. So this is an opportunity for actually us to have meta-reflection, meta meaning reflecting on the reflecting itself as we go, and we'll use that as an example. And so let's begin with the hard science of what we know now. And of course, things are always open to change. So when we talk about the science of neuroplasticity and we get into the neural science of it, we're really looking at the idea that neurons are firing, and as we've said before, what that means is that the basic cell of the brain, the neuron, with all of its supportive glial cells, which are many times more common, but they're smaller and they're not studied as much, so we don't talk about it as much. But these are the glial cells that include the oligodendrocytes and astrocytes. They're distributed all over the brain. We used to say, and often still do, they're supportive of the neurons, but I think we shouldn't be so clear. They're there, and we just don't know that much of what they do. Some people call it the other brain, and it's an area of excitement because there's more to learn. There's always more to learn. But we're going to look at the neurons, and in particular we're going to look at how this basic cell connects with other cells at the fundamental unit of connection called the synapse. And it's that synapse which allows neuron A to communicate to neuron B by the release of the neurotransmitter, and it's floating across the synaptic cleft, the space, and the activation of the downstream neuron. This is just a review. When we say neural firing, what we mean is neuron A fired, released neurotransmitter into the synapse before the downstream neuron called the postsynaptic, after the synapse neuron B. And this firing that happens is basically ions moving in and out called an action potential that then ultimately leads to the release of the neurotransmitters at the end. This long length is called an axon, and it reaches either the cell body of the downstream neuron or the dendrite as the receiving ends of the postsynaptic neuron B. Now, when this is activated, you get the release of neurotransmitter, which can be excitatory, meaning the downstream neuron's membrane will open channels called pores. These ions will pour in and out, basically, different kind of pore. They're going to go in and out of the membrane, making it so the equivalent of a charge goes from the dendrite or cell body down to the axon of the downstream neuron. That's called an action potential. So when you hear the term neural firing or neural activity, we need to know that what that literally means is an action potential has been initiated in a neuron, that the axon of that neuron has reached out to many other neurons. And as it releases neurotransmitter, it can be either excitatory and lead to a more likelihood that the downstream neuron will fire off, meaning, yes, ions going in and out like a charge flowing down the downstream neuron, that's the action potential. Or they could be inhibitory neurotransmitters and make it less likely that this will lead to the ions flowing in and out the action potential going down the downstream neuron. The additive sum, if you will, of excitatory input and inhibitory input to a neuron ultimately determines does it fire or not. So an interesting thing about neural activity is that it's pretty much an on-off thing. You don't have a little trickle of an action potential go down because there was a lot of inhibitory stuff but a little more excitatory, so we're going to give a teeny bit of a firing. No, the neuron either fires or it doesn't. And so it's kind of like a digital process. It's either a 0 for not firing or a 1, it's firing. When you do the math, it goes like this. And again, if you've heard me talk before, you've heard these numbers, but just to review, 100 billion neurons in the head. Average connection of one neuron to other neurons, 10,000. So you have hundreds of trillions of synaptic connections. The number of on-off firing patterns of this spider web-like system is calculated to be 10 times 10 a million times, which is a number larger than the atoms in the known universe. So I'm not saying the synaptic connections are larger than the atoms in the known universe. I'm saying the possible on-off firing patterns of that combination. Okay, so that's thought to be, and humans are saying this, the most complex thing we know of in the universe is up in your head. Of course, that's why we call ourselves neurotic, because there's so much happening. And so this whole system then is very complex, and it is a complex system, meaning that it is open, it has influences from outside of itself that can impact its firings. It's capable of chaotic behavior, absolutely. You can see that in all sorts of ways, in regular life, in seizures, all sorts of things. You can see chaotic firings. And in the sense that it's nonlinear, meaning small inputs lead to large and unpredictable results. So as a complex system, it has certain rules of self-organization that are the emergent property that arise from the fundamental elements of the system, which you could think of as neurons, or you could think of it as neural firing. And the neural firing, ultimately, what is it? It's electrochemical energy. Electro meaning the ions are going in and out, and the movement of a charge is electrical energy. The chemical, the neurotransmitters being released. So the simplest way of defining this complex system of all these huge combinations of interconnected neurons is the simple statement, electrochemical energy transformations, or flow. Now that becomes very interesting because when certain energy patterns happen, they contain symbolic value for us. So it's these energy transformations in the brain that subserve information experience in the mind. So there we see a very interesting thing, that the mind, yes, is about energy flow, but it may be the mind itself, the experience of mind, that is extracting information from electrochemical energy flow in our nervous systems. And I say nervous system here because this flow, of course, is happening not just up in your head, it's happening throughout your body, around your heart, around your intestines, in your muscles, in your bones. It's happening literally all around. So we say that this nervous system is embodied, it's fully embodied. We could call it the embodied brain if you want. But we'll look at the skull because it's easier to do. You stick the person in a scanner, you study what's happening in the head. But we need to understand that for our purposes in neuroplasticity, we're looking at energy and information flow. And when we say the word experience shapes neural structure, the definition of neuroplasticity, what do we mean by experience? We mean energy flow through the nervous system. Now, of course, there's always exceptions. So sadly, if someone gets run over by a truck, yes, their nervous system will be affected by the truck having run over their body. So yes, you can be affected by something directly because it physically injures the nervous system. But when we say neuroplasticity, we're really not referring to something gross like that. We're talking about the fine tuning of the nervous system based on energy coming into it, which is what experience is, the nervous system firing in certain patterns, so neural profiles, you can call it, neural net profiles, firing patterns, all these would be synonyms. And what that means is of the 100 billion neurons, in a simple way, which ones are on and which ones are off over a series of time. And of course, this becomes a fascinating issue. And though the neuroplasticity part of this isn't really talked much in Daniel Stern's book on the present moment, we have to say, well, what is a moment of time in which neural firing is doing what Donald Hebb said in his 1949 book, The Organization of Behavior, that basically the firing of neurons in one pattern at one time will lead to an increased probability of a similar collection of neurons firing in the future. So that was Donald Hebb in 1949. Sigmund Freud, 70 years earlier, had a very similar statement that we don't know if Donald Hebb ever read Freud or was familiar with Freud's law of association. And in the law of association, and maybe it was just 40 years earlier, I'd have to do my own memory system, I'd have to get exact numbers, but almost half a century earlier, Freud had come up with a similar idea of the law of association. And in the law of association, you would put together this notion that things which fired in the same timing would tend to fire in the same timing in the future. Now, Carla Schatz, in more recent years, and inside of me I'm reflecting, don't come up with the exact year because I can remember what she told me on the phone and I don't remember exactly the date, because I called up Carla Schatz, who's a neuroscientist at Stanford University. And I called her when I was revising the Developing Mind because I said everybody attributes the phrase neurons which fire together wire together to Donald Hebb. And I've even met with some of Hebb's students and asked, did he ever say that? And they said, no, I've read his books. He never said that. He said the idea of it, but he never said the actual fun phrase. Carla Schatz is the person who actually created the phrase neurons which fire together wire together, paraphrasing and acknowledging what's called the Hebbian law, or the Hebbian synapse, or the Hebbian axiom, this law, this principle. Hebb, H-E-B-B, was a psychologist and I think also a physician who taught this important idea that neurons which fire together wire together, but he never said it. Carla Schatz said it. So I once said to Carla, because I called her up on the phone, I said, is there any other thing? I said to Professor Schatz, that Donald Hebb said this thing, but, it wasn't such a rhyme. You came up with neurons which fire together wire together. She said, oh, yes, I have another one. I said, what is it? She said, well, people don't like it so much. I said, well, tell us what it is. Can I make it public? She said, sure. Fail to sync, fail to link. Maybe you don't like that one as much. I think it's cool because what it reminds us of is the synchronization of firing, that is, fire together, leads to the linking structurally of the neurons that are firing together. That's the wire together. So it's a very similar thing, only with sync and link. Okay, so you get the idea that the firing of these neurons is important. And so, for example, if someone's eating an ice cream and gets bitten by a dog, there will be an association of the pain in the hand from the bite, the fear of the dog, and the taste of the ice cream. So it is possible that that child bitten while eating an ice cream cone will avoid all ice cream. Maybe it was strawberry-flavored ice cream, and they'll avoid all strawberries, too, and strawberry ice cream, and strawberry rhubarb pie, although that would be hard to avoid, wouldn't it? This could all happen because of the law of association, Freud's term, Hebbian synapses, Hebb's term, neurons which fire together, wire together, Schatz's term. So in all these different ways, whether you're looking at Sigmund, Donald, Carla, or you, we just have to have the feeling inside of us that all of these associations are time dependent. That's the crucial thing. Well, how does that happen in the brain? How does that really happen? This is the notion, and Eric Kandel, in his beautiful book In Search of Memory, summarizes his own journey. He's a psychoanalyst who's also a neuroscientist at Columbia University. And what we learned from Eric Kandel, and he won a Nobel Prize in 2000 for this, is the idea that when neurons fire, when A is firing off and B is firing in turn, you get the activation of genes. And the activation of genes leads to the growth of connections among neurons called synapses. It can strengthen them in all sorts of ways. It can lead to more neurotransmitter being released. It can fine-tune the associations. So synaptic modulation is based on experience. So what Eric Kandel won the Nobel Prize for is this, that when an experience is happening, neurons are firing. That's number one. And when neurons fire, then what happens is genes are activated. Now, what does that really mean? An activation of a gene means you have the double helix DNA. The double helix DNA is then activated in ways we don't exactly understand the mechanism, but the neuron is firing, it's activated, and the double helix DNA will unravel its twisted form, and then you will actually transcribe from the double-stranded DNA one of the strands into single-stranded RNA. So deoxyribonucleic acid is DNA, ribonucleic acid is RNA. It's single-stranded. It's going to be transcribed from one arm, if you will, of this double helix DNA. The single-stranded RNA, a clip of it, a section of that gene, will then float from the nucleus of the cell, in this case the neuron, and go out of the nucleus into the larger soma, the body of the cell itself. There's an organelle called a ribosome, which will translate from the single-stranded RNA, that sequences of nucleic acids on the RNA, which came from the sequence on the DNA, which you inherit from your mom and your dad. It will then take that sequence of RNA nucleic acids, and it will turn them into amino acids of proteins. Those proteins being formed will ultimately participate in the change in the structure of whatever cell you're talking about. In this case, we're talking about neurons. So what Eric Kandel was able to show was that experience leads to neural firing leads to the activation of genes leads to the synthesis of proteins, the synthesis of proteins changes the structure of the nervous system. And that's it, in a nutshell. Now, when I was in medical school, the person who was my neuroscience teacher and mentor, David Hubel, he won the Nobel Prize back in 1980, 20 years before, for showing a very similar thing, which is that the experience that animals have, in this case it was kittens, during important windows of opportunity of development, are dependent on the stimuli from the environment. So that the actual structure, in this case, of the cerebral cortex and the way that the different columns within the cortex were going to be set up was dependent on the experience that those animals had. So Hubel's important work, and he won the Nobel Prize, Wiesel and Hubel won the Nobel Prize for this very important work of showing how experience shapes the structure at the cortical level. And then 20 years later, Eric Kandel, working with very simple systems of aplesia, was able to show that these neurons link up by activating genes. I will bet you that Michael Meany, this is my guess, who did very important work on epigenetic regulation of neural growth in rats, I wouldn't be surprised if he won a Nobel Prize, I don't know when, but for his important work of showing that caregiving actually changes not only neural structure in areas of the brain in a rat that control the response to stress, but he was able to show that they also alter the epigenetic control molecules sitting on top of the genes and part of the genome in those neural areas that help actually regulate the response to stress. So what we're saying here is a couple things, and let's outline it for the big summary of what we know about the neural aspect of neuroplasticity. We know that you can change the structure and function of the nervous system by experience by 4 ways, and we've only talked about 2 so far. We've talked about synapse growth and modulation, and we'll just call that synaptogenesis, but you could have synapses already formed, so you're not just generating new ones, that's what genesis means, but modulating them. So to be formal, you could just call it synapse modulation for both growth of new synapses and modulation of existing ones, meaning make them less strong, make them stronger, all sorts of things you can do. So synapse modulation. You also have what we've said is epigenetic changes. So you're not only activating genes based on epigenetic controls, you're actually changing the epigenetic controls themselves. We know from the work of Fred Gage, who is often called by the nickname Rusty, which I always think is funny, Rusty Gage, So Rusty Gage showed as well that areas in the brain in the adult, in the hippocampal area, adult human being, continue to grow as well. We know, of course, new neurons grow in utero. What we didn't know is that they continue to grow, at least in the dentate gyrus of the hippocampus, they continue to grow in hippocampal regions throughout adult life. So that's called neurogenesis. And neurons can be stimulated to grow, for example, with novelty, and after about 4 to 6 to 8 weeks, somewhere around 1 to 2 months, they mature, set themselves up in the cortical system, and then make their branching connections and become fully synaptically mature neurons by around 2 months or so. So there's neurogenesis can be stimulated by experience too. And then finally, so we have synapse modulation, neurogenesis, we have epigenetic modulation. The fourth thing we need to know about involves our glial cells, and that's where they help lay down myelin. So myelin growth allows for basically, here we have our neurons A and B. If these are going to fire together repeatedly, over time, not only will we strengthen the synaptic connections between them, and if we needed to, we could grow new neurons, so neurogenesis. We might even regulate the gene expression in this area to optimize the way these neurons are going to fire. So we've got neurogenesis to grow the neurons we need, at least in the hippocampus. We've got synapse modulation, so strengthen the synapses there, grow new ones as needed. We have epigenetic modulation, make it so if this is something we're doing, let's make it easy to grow new neurons there by modulating gene expression. That's the epigenetic change. Now let's make sure we review this. So this is to iron it into your memory system right now. So yes, you're hearing 2 things about epigenetics. We're saying you're using the activation of genes based on the regulation by epigenetic molecules. Yes, you got that. But we're also saying the actual experience modulates those molecules that are there, optimizing it so that if you're stressed out, for example, it's going to optimize your stress, and that's not always a good thing. So you may be more reactive to stress. Or if you're playing an instrument, it may make it easier for you to lay down the kind of movements you need because that's what you're doing. And if you're not doing that, you're more like a basketball player. You don't need to be doing these fine-tuned movements. In fact, maybe you shouldn't be doing them. So it's going to optimize neural functioning by modulating epigenetic controls. So that's the third thing. The fourth thing we're now talking about is myelin. So A and B are firing together. We've laid down neurogenesis. We're doing synapse modulation. We're optimizing epigenetic control. The fourth thing we're doing is we're going to lay down myelin. So the glial cells around these 2 big old neurons is going to wind this sheath around the neurons and then wind it around this one so that you've got this basically a conductive sheath that allows the action potential to go down from the receiving dendrite end or the receiving cell body down all the way to the axon end 100 times faster. Same thing on the downstream neuron, so this will be a circuit that can fire 100 times faster. But let's not stop there. The resting period between firing, called the refractory period, will be 30 times shorter. So 30 times 100 is 3,000. So 2 big impacts of this 3,000 number. It's 3,000 times faster repeated firing. And because of the speed, if we get a whole system of neurons becoming myelinated. And this is what skill building is based on. So we have memory based on laying down of new neurons, synapse modulation, and epigenetic control for memory. And now we're building on this with repeated firing, so it's not just memory, it's building a skill. So skill building seems to be based on myelin function, and there's a beautiful book about that by Dan Coyle that looks at this idea of how you build skills based on myelin deposition. And that is a wonderful way to think about this 3,000 times effect, because what it does, and this relates to our overall notion, is how's this system working better when you're learning? Well, that's what neuroplasticity is all about, is it allows more coordination and balance of the system because, and this then relates to the law of association and the Hebbian rule and Carl Schatz's neurons which fire together, wire together, it allows the whole system to become coordinated and balanced in its timing. So notice that we've talked about 100 billion neurons. We're only talking about A and B here, 2 neurons. So the whole system, through neuroplasticity, becomes more fine-tuned. Now, when you coordinate and balance, what you're doing is you're allowing different areas to be differentiated and then linked, and we call that integrated. So overall, we say that these 4 processes, neurogenesis, synapse modulation, myelin laying down, myelin formation, myelinogenesis is what it's called, myelinogenesis, and epigenetic control allow for the coordination and balance of the system, which ultimately means it becomes neurally integrated. And that's what we're looking for optimal functioning. So that's our summary of the processes of neuroscience that help us gain insight into that. Let's turn next to the study of memory. So let's move on to understanding deeply memory. We've now covered the neuroscience aspect, which embedded within it the idea of genetics and epigenetics and how they relate to neuroplasticity. So now we're diving into memory. Now, with memory, we have an interesting word. It has a connotation to it. And when I'm speaking to you using a word, I'm literally sending energy to you through sound waves as you hear my voice, and also you're watching me talk to you. So you're seeing my face, you're seeing my hands move, you're having the physical aspect of visual input to your eyes. Now, the auditory channel is energy. That is, sound waves are the movement of air molecules, the movement of your tympanic membrane, and the activation of your acoustic nerve, your 8th cranial nerve, which then allows for neural patterns to go in. And I say the word memory, it would be very different if I said the word flannery or flattery or goofery, or if I made up a word shumanamnumni, like that, or something like that. So it's still energy, but now you are having a process happen in your very brain with the word memory that brings up memory itself. So if I said flannery, you might start thinking about something Irish. If I said Flannery especially. But I said memory. And so whatever that brings up in you, I, as someone connecting with you, need to think about your experience. So in me, this would have to do with my ability to have empathy for you. Thinking about, okay, what might someone else think about it? What might you be thinking memory means? So we're going to start with this discussion of memory by talking about your memory of the word memory as an example of what memory is. So energy goes in to you. If you were reading this, it would be with your visual thing. If you're just listening, it would be with the auditory channel. Either way, because with vision it's photons activating the light patterns that would show memory, memory as a word. It would still go in your brain through your optic nerve, right? And through your optic nerve, you'd be activating cells on the back of your retina, which activate the optic nerve, which would go in and cross over in all sorts of interesting ways, which basically would activate your visual system that's making an map of the three-dimensional world in the back of your brain, the occipital cortex. You would also have, through the sound, if you're hearing my voice, things go through your temporal side, these side areas for your auditory cortex. And you would be taking the firing patterns for memory compared to O'Flannery, and you would be having a very different set of associations. So the law of association, the Hebbian synapse, neurons which fire together, wire together, all of that is about how you are going to make associations with this initial input of memory. So with empathy, what I'm doing is trying to not only imagine other people I've met and what they've thought of the word memory. So I'm an educator, I've taught many people now, and I have conversations in workshops, and I'll say to people, what does memory mean to you? So part of what you're experiencing right now with me is that I have remembered my experiences, which means what? Yes, energy and information flow, that is what experience is, that's happening between us and within us, and the within us part is the neural firing part. So it's happened inside of me that people will say, well, memory is when I remember something that happened to me. And then you say, what does that mean to remember something that's happened to you? He says, well, when I try to bring to mind something that happened to me. Well, that's one part of memory. It turns out that there's many other layers of memory we'll talk about right now, so that they all involve the fundamentals of what we said. Neurons have fired together, and they've wired together. So you may have been taught that the word memory means I, right now, am recalling something and have the feeling that something that happened to me before is affecting me now. In fact, I remember when I rode a bike in Yosemite once, Yosemite Park, it started to do a hailstorm, and the bike got very slippery, and I fell. And I remember now how strange it was to have a hailstorm in early fall in Yosemite Park in California. So I'm telling you basically when it was in the fall. I'm telling you things that I'm remembering about it. That's one form of memory. But I might also get on a bicycle and start to get frightened that I was going to slip if it started to hail. And I wouldn't even know in my conscious experience that this was influenced by something that happened to me in the past. And that's a different kind of memory we're going to get into now. So these different aspects of memory don't always involve the experience of bringing to mind something on purpose. Now, if you remember from earlier in this digital journal, we have the 3 stages of memory: encoding, storage, and retrieval. So let's review those now that we have the neuroscience of neuroplasticity under our belts. Encoding means neural firing that leads to either temporary or more long-lasting increases in the associational firing, the connectivity of neurons. So let's do an example of the temporary encoding. You're hungry. You want to get a salad. You look up on the net the phone number for a local restaurant. You remember the number in your head. You then dial the number and ask for a goat cheese salad. Then you hang up the phone and you remember the address and you go get the goat cheese salad, and now you're walking back to your office. You forget the phone number, but you remembered it long enough to dial the number. So you encoded it temporarily, you stored it temporarily, meaning encoding, meaning you had the experience that was about to alter the neural firing associations. They stayed linked, so you had the number 1, 2, 3, 4, 5, 6, 7 as the phone number to call. You then dialed the number with them held in place there, and then because it's important we not remember everything we encode or we'll go nuts, you got to selectively to choose which things to have changing your brain structure. You let that go. Now, if it's a deli you're calling, every week, pretty soon it would be useful to you to remember the number. But a place that's a one-off and you only dial it once, you don't need to remember it. In fact, you shouldn't remember it. So Temporary firing seems to be a chemical change. There's a way neurons can temporarily increase their associational processes. So you encode it through looking at the number. You store it temporarily, making these chemical associations, not structural ones. You then retrieve it when you're picking up the phone. You dial the number. You then let it go. You can call that forgetting, if you will. So one kind of encoding is temporary, and that's fine. You can have more long-term encoding. What does that mean? That means the experience happens, that's the encoding. The storage is going to require that you activate genes. So fascinating studies, again by Fred Gage and others, show that when neurons fire together, the rewiring that happens is based on the activation of genes. And if you give gene expression inhibitors of various sorts, you can demonstrate that you will not get storage in a structural terms of that experience. So that's a very important thing when it comes to understanding trauma, for example, that you can have the encoding of an experience but block its storage. It also is fascinating for attachment issues. When you study the 20% of the U.S. non-clinical population that has avoidant attachment and then goes on into adulthood and probably develops what's called dismissing adult attachment, my clinical impression is they don't remember their childhood experiences in terms of relationships, not because they can't access them, because I think they've never stored them. Having had the opportunity now to do the math, but 85, 95, for over 25 years now, doing the adult attachment interview with my patients, they don't suddenly, somehow, somewhere, in some mysterious moment in psychotherapy, come up with this volume of memories of their childhood. They don't recall them, even when there's no reason for them to be hiding them, which sometimes can happen in the setting of a limited 1.5 hour interview in a research setting. But having spent years and years and years with folks, I can tell you, I don't have any clinical impression that they have encoded those things. They just haven't encoded them, so we can see why. If something isn't important to you, you don't encode it. Okay. So you have change in gene expression, which allows for the deposition of these alterations and associations called learning to be embedded in storage for memory. Now, what happens then after that? Well, there's something called long-term storage, and you can retrieve that. And what's interesting about that from a structural point of view in the brain is that when you're going from laying down memory in, now we're going to talk about 2 layers of memory, the layer that's called implicit memory, which is the basic layer, and the way I think about it is kind of like the building blocks of memory. This includes perceptual memory, like, for example, for that child who's bitten by a dog while eating a strawberry ice cream cone, you would have the perception of the dog. You might have the bodily sensation, that's probably implicit memory but not usually studied, of the taste of the strawberry ice cream. You would have the emotion of the fear, and you also have the sensation of the pain in terms of bodily sensation, the emotion of the fear of the dog, and you would also generate let's say a bodily impulse to run, so a procedural or behavioral or motor memory. You might generalize that experience, especially if you got bitten again, as all dogs are bad or all ice cream is full of danger. All sorts of mental models will be developed, and priming, getting yourself ready. So those are the 6 essential elements of implicit memory. Perceptual building blocks. You have the bodily sensation, probably would fit into there. That's not as well studied. You have the emotion. You have the behavioral response. You have the generalizations as mental models. And you have the getting ready called priming. So that's the fundamental layer of implicit memory. As we'll see, implicit memory by itself, when it hasn't been more integrated into the nervous system through the hippocampus, when it's only in implicit form, it has a unique feature that when it's retrieved, so it's encoded through the initial experience, it's stored, yes, in various regions of the brain. Throughout the brain, you have implicit memory stored, left and right, up and down. And then when you retrieve it, it can enter consciousness, but it doesn't have the tagging of what I call an ekphoric sensation. Ekphory is the match between a cue and the retrieval of a memory. So an ekphoric sensation is just a term I made up for the feeling like, aha, that happened to me in the past. It's like a red flag. This is from the past. Implicit only memory. So implicit dash only, when it's only an implicit form. Implicit only memory does not have an ekphoric sensation. It just arises in consciousness like any retrieved memory can. It doesn't have to, but it can. So it's not the same as unconscious memory, even though that's what a lot of people call it. They make implicit and unconscious synonyms, and they're not, as far as my interpretation of the science goes, because implicit memory, when it's activated, can be fully conscious. Only it has no ekphoric sensation, so you don't feel that it's coming from the past. It can just flood you in the present. Now, when the hippocampus at 18 months of age becomes mature enough, it starts to, is my interpretation of the science, weave together those basic building blocks of implicit memory and form explicit memory, with two major forms of this layer of memory. Explicit factual memory, which according to Daniel Schachter, if you read his work, is dominant on the left side of the brain, and episodic memory, that is, remembering yourself in an episode in time. That's an Endel-Tulving term, Tulving, and that's where you have memory of yourself at a particular time. And collections of episodic memory are often called autobiographical memory. That is, all the times I eat ice cream, all the times I've been bitten by a dog, all the times I went to grandma's house and had fudge. I must be hungry or something. I keep on talking about food, but, although I'm not hungry. Anyway, I just thought maybe you're hungry after hearing all these details. So, you have explicit memory, left side facts, right side dominant for episodic memory. What is an episodic memory? Self in time. I remember this time I was with my grandma going for a walk by the pond. I was 7. I feel I'm remembering it. So the key thing about explicit memory is it has an ekphoric sensation when retrieved. Retrieval of hippocampally mediated explicit memory is integrated into a much more complex form, in that you're collecting many sets of it to make facts, you're collecting many sets of it to create autobiographical details, and both those cases of factual memory, which doesn't have self or time, but does have an ekphoric sensation, and autobiographical memory, which has facts of the self in time, and that feeling of the self in time as remembered, I'm remembering now, that's the ekphoric sensation. That's the key thing. Now, coming back to what we originally were talking about, is, when you are coming to this moment in the retrieval of a memory, and you're saying, can I really remember this now? Is this really something happened to me? You get the retrieval moment when it's explicit. You can get it in the form of, oh yes, now I'm remembering a fact, or oh yes, now I'm remembering when I was 4 and I was bitten by a dog while I was eating strawberry ice cream. That would be an explicit form of that memory. And when we do that, then we're retrieving it. So we have the encoding, we have the storage, and depending on the layer of the storage, it can be implicit only. And then we have retrieval. If it's retrieval only in implicit forms, it comes out as, this way in which you've have the subjective experience within consciousness of the knowing and the known. That's consciousness. The known in this case is just strawberry ice cream, dog bite, not the ekphoric feeling of, I'm remembering that happened to me. You just have that feeling. So it's in consciousness, but you don't know it's coming from the past. Or if it's gone through the process of integration by the hippocampus, it also has this quality of, yes, strawberry ice cream, dog bite, I remember when that happened to me when I was 4. This kind of thing. But when I was 7, I went with my grandma and she talked to me about it, and we created a narrative about it, which I'll tell you about in a moment. So the purpose of going through all that as a parenthetic, first of all, is we needed to go over it. But secondly, the original thing is what happens with this storage. We said you have temporary storage, and it goes away with the deli and calling for the goat cheese salad. Then we have more long-term storage, which is I remember the goat cheese. Now this is like 10 minutes later, so that wouldn't be just immediate memory. That would be more temporary, intermediate storage. But then you have long-term storage. And what's fascinating about that is if I were to talk to you, let's say 5 days from now and say, what was on that goat cheese that I talked about in the digital journal? And you said, what was on the salad? And you said, goat cheese. We would know that to last that long, you would probably need to have changed some kind of structural changes in your brain. And what's fascinating about it is retrieval has these two interesting qualities, that for the first several days, if not weeks, following an experience, let's just call that long-term storage. To get retrieval of long-term storage, you are going to be using your hippocampus to retrieve that from storage. Fine. If it's explicit, you'll have a sense of remembering it. If it's implicit, fine, it'll just come up and that'll be there. But here's the fascinating thing that happens, is that after a few weeks to months, you will no longer need your hippocampus for retrieval of long-term stored memory. But the experience, encoded, now stored, will become what's called permanent. And then what we believe is happening, and I remember myself asking Eric Kandel this back in the early 90s when he was on a stage with my research mentor, Bob Bjork, B-J-O-R-K, and Robert Bjork, who is very active at the UCLA psychology department. He would teach all of us. We had a group we used to meet called CogFog, and we would always talk about these issues, but he had this beautiful phrase, memory retrieval can be a memory modifier. And so when we talk later on about what you do with memory in terms of undoing learning, Bob is an expert in that, and what we want to say here is that this act of retrieval is a moment to actually change the way the retrieved, stored memory profile will be restored, that is, put into storage again, and it can be put in a different form. And that's a very important issue for changing things. The finishing touch I want to make on this process is that when you've gone from retrieval using the hippocampus of long-term memory to retrieval of permanent memory, what Eric Kandel said in the meeting with Bob Bjork back in the early 90s, and again I asked him, he gave a delivery right after he got the Nobel Prize in 2000, and I got up to the microphone and asked him this question at the American Psychiatric Association meeting, and what I remember asking about was, could in fact the difficulties people have with memory not only be what I suggested in 93 was some blockage of the hippocampus during a traumatic experience, which would block explicit processing, and the increase of adrenaline increase implicit encoding. But could it be that people hadn't figured out yet that the second layer of going from long-term to permanent storage involves something called cortical consolidation? So what I said to Eric Kandel was, could it be that cortical consolidation, which people really didn't understand, would be the mechanism that psychotherapy needed to harness to allow someone to go from unresolved trauma to resolved trauma? And he gave this beautiful response. He said, young man, he goes, I think that that's a great idea and you should pursue it. He goes, I just have a Nobel Prize. It doesn't mean I have answers to everything. And it was very humble of him to say that. And he then went on to say, people think if you get a Nobel Prize, you know everything. He said, you don't. He said, you just did one area of research. You get acknowledged for it. It's beautiful, but it doesn't make you any more expert at other things. It was quite interesting. The issue here is that cortical consolidation seems to involve, and this is really open for exploration, but it seems to involve REM sleep, which activates, in my interpretation of the data, this process of eyes moving back and forth and back and forth. And when you combine that finding with the study that moving the eyes to the left activates the right brain, moving the eyes to the right activates the left brain, this process may be a left-right, left-right, left-right process. And this would correspond with Endel Tolving and colleagues' HERA model, H-E-R-A, which is the hemispheric encoding and retrieval asymmetry proposal, which there's new evidence to support it. The idea being, just to summarize it here, that there's something about the process of autobiographical consolidation of our experiences that involves the left hemisphere and the right hemisphere in an encoding and retrieval process, and that dreaming may be the way cortical consolidation happens by involving the integration of the left and right hemispheres in their differentiated roles in memory processing. So, let's summarize all of that and make sure we're all on the same page. Memory involves 3 steps: encoding, storage, and retrieval. And right now, what I'm doing is I'm repeating it so that we see that repeated firing lays down more wiring. So this is why I'm repeating it. Encoding, storage, and retrieval. And if I ask you to say it out loud, you'll be actively learning because you'll be activating more circuits. So one thing we could say, just for good old learning, learning depends on memory, memory depends on practice, and the more you engage your whole body, visual, auditory, kinesthetic, the more you'll learn. Just like a passive reader who just reads without asking questions about it, doesn't remember as well as someone who reads and actually engages with the material, pauses and thinks, what does that mean? What does that mean? Why did the author say that? Why did the character do this? What does that mean? How does that relate to this? Active learning is something you can do right now. So you might say encoding, storage, retrieval. Excellent. Now, let's go to the next layers. The 2 layers are implicit and explicit memory. The 2 layers are very good. And implicit memory doesn't have an euphoric sensation when it's in pure form. And amazingly, just to finish that up, you don't need attention with consciousness. So consciousness is the act of knowing, of being aware. Let's use those as synonyms. And attention is that process which directs energy and information flow. So consciousness and attention are different. When you have energy and information flow that's being harnessed with consciousness, it has a very specific name, and that's called that's called focal attention. And when you have attention without consciousness, it's called Josephina. It's called non-focal attention. So focal attention is what you need for the hippocampus to get involved to integrate explicit memory, but it turns out that implicit memory not only doesn't have euphoric sensations when you retrieve it, you don't need focal attention to deposit it, which means if you can divide your attention, you can only process that which you're focusing attention on an explicit level, but you cannot block implicit encoding even if you divide your attention. Now, that becomes extremely important when you look at the mechanisms of dissociation. When people dissociate during a trauma, they're dividing their attention, meaning they're focusing their focal attention on some aspect that's non-traumatizing, some flowers on the wall, like these paintings over here. I focus there, my body's being intruded upon, so it is possible for me to shut off my hippocampus because I'm focusing focal attention on those flowers, a whole field of flowers. This is happening in my body, but I'm not going to pay attention to it. I'm not going to pay attention to it in consciousness, but I can't block non-focal attention. So implicit encoding of the trauma to my body happens, but I only explicitly encode the imagination of an entire field of those flowers. That also can explain how the hippocampus gets usurped by focal attention being divided into dissociation. And if I also flood the hippocampus with cortisol, stress hormone, I can stop it temporarily from functioning well. But even with cortisol blocking explicit encoding, that is the integration process of these implicit layers, I cannot block implicit encoding no matter how much cortisol I secrete. So this is an explanation for the impact of trauma on memory systems by either dividing attention and stopping the hippocampus, linking together what I'm experiencing through focal attention into the explicit forms for that traumatic event, and I can also block it with cortisol. In both cases, and you can have both going on at once, I have basically kept implicit memory of a traumatic event in its implicit-only form. When it gets reactivated in that status, it can look just like, experience just like, feel just like a flashback. So what you've just encountered was the way we're using everything we've just talked about to understand some elements of post-traumatic stress disorder, including flashback phenomena, the intrusive feelings people get, the sudden images they get, all sorts of ways of understanding implicit-only memories. When they're blocked from being integrated by the hippocampus, they're kept in a form that can explain much of the profile of post-traumatic stress disorder, and it gives us an insight into what healing trauma needs to involve, which is using the hippocampus to actually integrate implicit-only memory. Using Bob Bjork's notion of memory retrieval can be a memory modifier, we then can move toward resolution by integrating these non-integrated memory systems. Okay, so we've talked then about 3 steps of memory, 2 layers of memory, and what we're going to talk about next is the way attention is used in an emotional setting to actually build the positive aspects of experience and neuroplasticity. So we've been exploring neuroplasticity from the view of neuroscience and memory. And now we come to our next section, which is all about how do the experiences that happen with our focus of attention, the garnering of our social relationships, and the emotions involved support optimal learning. So when we think about the last digital journal, which was all about social emotional learning, we can review here to help consolidate what we've been experiencing by practicing it. We probably are dreaming about it, synthesizing left and right hemisphere aspects of it. And we're going to talk about these from the point of view not just of social emotional learning, but how we use the principles of social emotional learning to optimize learning of anything. So the first thing we need to say is that everything we've been talking about action potentials, about the activation of genes for gene expression, about the way you're going to have different layers of memory get involved, refers to this hierarchy of implicit memory, for example, being laid down with an experience, focusing attention within consciousness called what? Focal attention that then allows factual and autobiographical elements of memory to be laid down. And then, as it's going from temporary storage, so you have encoding, storage, retrieval, encoding for explicit things is going to require focal attention. Storing things in ways that then are as highly linked to each other will deepen the connections that are involved. So we're going to look into Ellen Langer's fantastic work on mindful learning and explore that a bit. And then the more linked they are together, actually, the more we can then go from implicit memory to explicit things. So we have autobiographical knowledge, we have factual knowledge. But then how do you go from long-term storage to permanent storage where things become a part of your world understanding and not just something you have to hold on to in memory? And that's called cortical consolidation. And in cortical consolidation, what we've seen is there's something about REM sleep. There's something about bringing the left and right hemispheres together. There's something about becoming freed from the hippocampus. So one classic set of studies that you may know about and gets us into this is if you've been in let's say a motorcycle accident, let's say on January 1st, you find in the hospital where you had this after head injury from the accident, you don't remember anything happening in the hospital from January 1st to February 1st, right? So that's this proactive, this going forward, anterograde, right? This anterograde amnesia means everything that goes now following the accident you can't remember explicitly. People come to visit you don't remember them visiting you. You're trying to read, you don't remember what you read. But you also don't remember retrograde. Since your accident, you can't remember what happened in December, maybe even in November. But you do remember what happened in October because you consolidated that. So the hippocampus is very vulnerable to being hit. and can't remember as well when it's shaken up physically, right? So you have both retrograde amnesia and anterograde amnesia. This understanding helps us see that those experiences that were consolidated did not need your hippocampus to retrieve them, like your identity. And this becomes an important issue here. So ideally, what we want to do to optimize learning is make it integrative. And what I want to suggest to you is these stages of implicit layer, right? You have the implicit layer, you have the explicit layer, and then what I'm going to suggest to you is that there's also a narrative layer of learning, where the narrative, which is the linear telling of a sequence of events, in my view, this isn't everyone's view, but in my view, it's a profoundly integrative left and right process that's at the heart of dreaming and at the heart of cortical consolidation. And we do this through engaging with both self-reflection, inward reflection, and in the teaching we do with each other. So you can then come back to the subtitle of this digital journal, which is about how does self-reflection and discipline cultivate cultural ways? How does it work in our culture? How does it work in our families? How does it work in our schools? Throughout this way, how do we cultivate this kind of integration throughout our lives, whether we're walking around and reflecting on things ourselves, whether we're engaging with a parent or a teacher, or even with friends, with close family members? How does this process all unfold? So learning then isn't isolated to just the classroom. It's in our whole culture. And this becomes something we can actually support in each other. So let's review that as we dive into it. What we've said is that energy flowing through the nervous system is what we mean by experience. The nervous system can have certain firing patterns that become used by the mind as symbolic. They stand for something other than just the firing pattern. So if I go, you may have all sorts of associations with that perhaps, but in general, it won't have symbolic value. If I say memory or if I say Golden Gate Bridge, those have symbolic value. Your brain firing based on prior learning, implicitly, explicitly, and maybe narratively, is going to embed certain meaning to those experiences of things I do here. Okay, so what we're saying is that experience is neurofiring. Attention is that process which directs the flow of energy and information through the nervous system and through our relationships. So attention as a process of the mind, as we've talked about in the prior digital journals, the mind is both embodied, so you direct energy and information flow within you, and it's relational. So attention also directs energy and information flow between ourselves and other people, or even between ourselves and the planet. You can direct it in a relational way. So we have, just to consolidate this in our narrative that we have with each other, we have the process that energy is flowing through us and floating among us, in terms of encoding. That's what an experience is, and when we put it through our nervous system, we have encoding. We have the changes, either temporary or intermediate or long-term or permanent, in our nervous system called storage, and retrieval is taking any of those forms of storage and activating it. So that's laying down that. Now we have the issue of attention, which when it's within consciousness is called focal attention. But we also direct our attention even without consciousness, which is called non-focal attention, and we can learn in both ways. You can learn implicitly with non-focal attention or focal attention. You need focal attention for explicit learning. That's great. Now, for cortical consolidation, what I'm going to suggest to you is we also want to have meaning that's extracted from experience, not just factual data of self and time for autobiographical memory, facts for factual memory, or even implicit layers of perceptual memory, bodily sensory memory, emotional memory, behavioral memory, mental models. All that stuff, doesn't require narrative, but narrative can be influenced by that. So when we think about then attention, we're talking about focal attention, allowing you to take part, whether it's the first thing we've talked about is self-reflection. The second thing is in terms of discipline, how do we actually have a teaching process emerge between two people, especially an adult and a child, in the parenting situation for discipline, but even encouraging this reflective process. An active engagement of focal attention is a simple way of defining self-reflection that looks inward. So you're having internal attunement would be focal attention inwardly that examines what's going on inside of yourself. Discipline would be focal attention happening interpersonally, so between you and another person. So in many ways, you could call it almost self-discipline in terms of self-teaching and interpersonal discipline, if you will, or which we usually just use the word discipline. So they're very much related, actually. And in the interpersonal part, we often use the word of reflective dialogues. Now, what does this mean to extract meaning from experience? What we're saying is that part of the attentional process is to evoke emotion and significance in the teaching process. And if we're talking about the self-reflection process, let's say in journal writing, we're talking about allowing things to arise that have meaning, that are significant, that are important, that have a punch to them, that have value. Now, the work of James Pennebaker, starting with self-reflection, is extremely important because in Pennebaker's work, he shows that the act of journal writing can profoundly improve our immune system when we've had a trauma. It can improve our sense of well-being. Even if we never show that journal writing to anyone else, it actually improves the act of reflecting on our own experiences improves our lives. So Pennebaker has done an incredible job of systematically studying how this act of self-reflection carried out through writing is so important. And for me, what's interesting about writing is that if you take the work of Endel Tolving, which suggests that the right hemisphere is dominant for storing autobiographical memory, and that the left is useful for encoding and the right for retrieval, and that you do this encoding retrieval thing in his HERA model, hemispheric encoding retrieval asymmetry model, HERA, and you combine that with Pennebaker's work, and you actually look at different dream studies, you can make the proposal, which I've written about in The Developing Mind, that the actual process of reflection is mediated interpersonally, intrapersonally with journal writing, and even when we're asleep in dreaming. So you have these wonderful opportunities to see that taking memory processing to its highest level of meaning making involves an integration across many layers, including the left and right hemisphere. Now, when you look at it that way, we come to this final word of our subtitle of the digital journal, neural integration. And we also come back to the very beginning of the digital journal when we said, hey, we've got all these neurons in the brain, right? And there's A and B here, but you got 100 billion of them. How in the world are you going to make this system work well? So what I want to suggest is we just take a deep breath and say, oh my God, this is so overwhelming, all this stuff is. I want to offer you and give you this moment to just pause and think about this process. That the act of making sense of life, which can mean making sense of experiences you've had for autobiographical narrative, it could mean making sense of what your teacher offered you in a classroom on history or mathematics. It could mean the discipline experience. And Tina Bryson and I have written a book called No Drama Discipline, which tries to reclaim the whole notion of discipline as teaching rather than what it's been taken over by in modern culture, which is punishment. So for us, for Tina and I, we see discipline as actually opportunities to teach and for children to learn rather than opportunities for parents to punish and children to be the victims of the punishment, or, if you will, the prisoners that are put in captivity. So discipline seen that way is really an opportunity for teaching. Now, how does that relate to emotions? Well, if you've read The Developing Mind, you may know, or even some other books like The Pocket Guide to Interpersonal Neurobiology or The Mindful Therapist, You know that for me, when I review the research on emotion, for me, the only way to make sense of the very wonderful but disparate approaches that the various scientists have about emotion is to take a step back and look at the consilient view, E.O. Wilson's term in the book called Consilience, to take a consilient view of those different scientists' views on what emotion is. And so my view on emotion is that emotion is actually a shift in integration. And a shift in integration means, for the brain, you're altering the way in which the linkage of differentiated parts is either downshifting, so in what are called negative emotional states that are uncomfortable, like sadness, persistent anger, fear, dread, shame, disgust. These are downshifts in integration that allow you to, yes, focus attention, but it becomes less of an overall integrated state, so you become either more chaotic or more rigid, two signs of less integration. Whereas in what are called the positive emotions, and I'm often hesitant to use those terms, but that's what the scientists are using, so we'll just put quotes around them, because no emotion is bad, it's just a shift in integration, and we could say integration is a healthy thing, it's the basis of well-being, so you want to uptick integration if you can, so then we can feel a little bit more at ease with our own emotional response to the word positive emotion. So there, a positive emotion is an uptick in integration. And in Barbara Fredrickson's work in Love 2.0 and in the recent workshop she and I did at the Psychotherapy Networker, what I proposed to her was that you can take a view of the whole field of positive psychology, even though they don't ever talk about integration, as really, at its deeper mechanism, talking about integration. So positive states like joy and elation and love are all about increasing states of integration. So when we look at the notion of how self-reflection and discipline cultivate cultural integration, and we think about this section of our digital journal, we're talking about attention being the process that focuses energy and information flow. The social being how we share that flow with each other, and the emotional side of that being all about integration. So in my own experiences as a student, years ago, back in 1990, I was given the opportunity to be in Jerome Bruner's course on narrative. And Bruner has a wonderful book, and let's see if my memory system works, called Narrative in Literature, Law, and Life. And I want to throw love in there, but I'm not sure Jerry would do that. But anyway, you can look it up, and we'll put it obviously in the background material. But in this book, you'll see that he wrote after this workshop, not a workshop, it was a graduate seminar I was in with him. In that seminar, Bruner taught some fantastic things, and of the many, many things I learned from Professor Bruner, this was one of them. That narrative happens, and narrative is defined as the linear telling of a sequence of events. So this is all Jerry Bruner's terminology. So a narrative is a linear telling of a sequence of events. It has two aspects to it, what Jerry Bruner would call the landscape of action, which he means events that happen, and a landscape of consciousness, which he really means the landscape of the mind, the inner mental experience of the characters of the story. So action and mental life is the way I would think about it. And that narratives are initiated when there's a violation to expectation, which Jerry would call a canonical violation, a canon being an expected way that things are. So I wouldn't tell you a story anywhere, if we were together walking around or even in a digital journal. I wouldn't say, okay, today I got up and my foot got off the bed, then the other foot got off the bed, and I went and I brushed my teeth, and then I rinsed my mouth out, and then I went downstairs. No, because nothing was violated. You go, why is Dan saying these things? You may not even call it a story. So a story is the way we make sense of violations to canonical expectations, to expectations of the way we think life is. So what I want to suggest to you is that part of what this complex system does of the brain is it learns from experience what to expect. We see that in all the different things about mirror neurons, and if you look at Marco Iacoboni's wonderful book, Mirroring People, you'll see embedded in there the idea that even the mirror neuron system learns from experience on what to expect. And when I once met with Andy Meltzoff, we were having dinner with Barry Brazelton, and I took the opportunity, because these are two guys who actually study a similar thing about infants, which is if you stick your tongue out at an infant, a newborn infant, she or he will stick her tongue back out at you. So I said to them, I said to Barry and to Andy, I said, tell me how many times you stuck the tongue out, your tongue out, before that infant did it. Was it ever on the first time? They go, no, it was never on the first time. The infant had to study you doing it, and then after many repeated times, then the infant would do it. Now, that doesn't take away from the magic of it, but the issue is that the mirror neuron system of that child involved in the perceptual system, and the whole idea of mirror neurons is they link perception with action of oneself, is that the baby at birth basically could figure out where her tongue was, so that as she saw these two dudes differently, they work separately, but when they saw a person in front of them sticking his tongue out at them, they could watch and figure out that they had a body too, that their brain could figure out where their tongue was, and they could do it in a repeat way. The issue there is that the memory systems that we have include the social systems. We're incredibly social creatures, and we are activating our attention. The social world is profoundly important, and part of what we want to do here is give this honoring of the way two nervous systems that are in two brains are actually part of one system. So the social part of this aspect of our digital journal is to say that learning is deepened when you, as a teacher or parent or therapist or friend or coach or whatever role you're in, when you take a moment and really allow the recipient, whether it's your athlete you're trying to coach, or your client or patient you're trying to support in their growth, or your child if you're the parent or other caregiver, or the student if you're the teacher, if you take a moment and really allow your system to take in the system that's of the people sitting in front of you, the social engagement will allow a process that we talked about in one of our first digital journals on presence to resonate with them. And then in that resonance, the state of integration is increased. So even if you're talking about very sad things, the increase in integration means you're honoring differences and promoting linkages between the two of you. And that state of the whole system becoming one unit is increased. So it's going to have a sense of elation, a connection. And this is the fuel that fires up learning, when you feel deeply connected to people you're with. And that's the social part. Now, when we say social emotional, what's so interesting about it is in the brain, and if we review what we've also talked about in past journals, our hand model, we have this moment of really reflecting on how this whole system is deeply social and deeply emotional. There isn't just one emotional part of the brain, and there really isn't one social part of the brain. The whole system, as Marco, we were once in a workshop, a think tank I was running, and he came into the think tank a little bit late. He said, sorry I'm late, but we just finished this study. We got the data figured out, and he did it with the Yitzhak Fried, where in open skull surgery they showed there were mirror neurons all over the brain, and way more than they ever thought they would find. And he was just so excited, and I can share it with you now. You know, his excitement, his connecting with us, his saying, I'm sorry to be late, but here it is. You know, it was just this incredible moment, you know, of being the first person with his colleagues to discover, you know, the actual neurons in the brain, not just mirror properties, but actually mirror neurons. So I say all that to you because as we get ready to bring this journal to a close, social and emotional just go together. The social is how we're connected with each other. Emotion is a shift in integration. So these aren't really separate processes. With reflection, as Pennebaker and others have shown, you actually deeply develop what Mary Main and her colleagues, Eric Hesse and others, would talk about as a coherent narrative. This deep making sense process is this wonderful opportunity to actually see this overlap of, for example, your coherence of the way you make sense of yourself, what's called a secure adult state, with what one of my former students, Amy DeNoble, has shown in her graduate thesis was this overlap between mental presence called mindfulness and adult security of attachment. We need more studies to elaborate on that, but the bottom line is there seems to be a deep overlap between how you make sense of your life and how you connect with others. And this is seeing presence for yourself and presence for others as a gateway toward integration. Now, there's a moment here where we can then take a deep breath and say, got it. We see this whole panoply about neural integration, which means how do you take different aspects of the nervous system and link them together, and the making sense process. And let's take a few moments now to reflect on that. So in these next few minutes, as we get ready to bring this digital journal to a close and to bring the year 2014 to a close for this series, I would like to reflect with you about a couple of things and try to illustrate some issues about memory, meaning, making sense, social, emotional, neural integration, all within the setting of neuroplasticity. So at this moment in time, this is actually the last digital journal we'll create here in this office. So the next time you see me in digital journal format, you won't have this particular background and we won't be in this room. So I'd like to take a few moments just to reflect with you in a way of things that are different from expectations perhaps for you in a digital journal and certainly for me in this moment of time, and how this involves the encoding process, the storage process, the retrieval process, the consolidation process, implicit, explicit memory, and the notion of narrative and making sense, and how that relates to social emotional connections, the idea of reflection, discipline, and neural integration. So here we go. This office and this building have been a part of my life for a long, long time. Every book I've ever published was published when I was in this particular office. Every patient I've ever seen in private practice has been in this building. I've been practicing psychiatry. I've been working as a psychiatrist for 30 years now, and I have been in this building for 27 years, and we are just about to move. In fact, this is the first day of the last week that we'll be in this building. Now, as I get ready to make sense of that for myself, I think back what this building means for me, and it starts even before I was a practicing psychiatrist. It starts when I was a medical student, and I dropped out of medical school in 1980. So that's a long time ago now, so that's 34 years ago if I did my math right. And my first time of ever being in psychotherapy myself was when I was a dropout from medical school, and I was very confused and disillusioned with medicine and very unhappy about what that professional training was like, so I dropped out and went on this journey, came back to Los Angeles here, and the psychiatrist that I chose, whose name was Don Siegel, sadly he's no longer with us, but he was on the 7th floor of this building. And the address of this building is 11980, which is 1980. And the first time, I ever went to therapy was in 1980. So I always would remember the address because I realized it was the first time I ever was in therapy was in that year. Now I share all that with you because in 1980, I was 23 and I was just trying to understand life, trying to figure things out. There were violations to expectations all over the place, and I was writing in journals all the time and trying to make sense of things. Betty Edwards had just published a book in 1979 where the apartment I was staying in, the woman next door was the first instructor for her book, The Drawing on the Right Side of the Brain book, and that book really introduced me to a whole other aspect of my own life. And when I think about these 30 years of being a psychiatrist, the 27 years being in private practice in this office, and now going to our new office in Santa Monica, I think deeply about how all these things have been a part of my life journey. In many ways, the notion of making sense of one's life that Mary Main talks about in A Coherent Narrative, and the mental time travel process that Endel Tolving speaks about, and the journal process that James Pennebaker talks about, can all relate, I believe, to creating integration within and integration between. And so while we talk about neuroplasticity, it doesn't have to be a passive process. The act of self-reflection, of the making sense process, through thinking about things, through journal writing, through connecting past, present, future, and mental time travel, this what Tolving calls auto-noetic consciousness, self-knowing awareness, is more than just being a historian writing things down. You are becoming the active author of your own history. And what I want to invite you to think about as we think about neuroplasticity is it's an invitation to really consider how we can change our brains. You know, Norman Doidge, I was going to say another Norman, but Norman Doidge wrote a beautiful book called The Brain That Changes Itself. And Norman and I used to run around the country teaching a workshop called The Mind That Changes the Brain. And what I want to invite you to realize is that you can use your mind to actively develop neural integration through your participation in neuroplasticity. You do this through being awake. You do this through regular reflective practice. Some people like to call it meditation. I like to call it time in, where every day you take time in and develop these capacities for self-understanding, for being present. For reviewing your history, the thing I love about the idea of time in and reflection is that it allows you to actually be very interested in memory, to understand the layers of memory that are always with you. You know, that the past isn't past, as some literary figures have said, the past is still present with us. And so this is where we can say the only thing that truly exists, is right now. Right now is what we have. And now. So neuroplasticity, even though it's about memory and it's about laying down skills with myelin formation, it's really allowing you to be fully present now and allowing the neural circuitry to be unfolding, laying down new neurons, which continue throughout your life, laying down synapses and modulating with synapse modulation, laying down myelin to allow this system to become ever more coordinated and balanced throughout your lifespan, and modifying epigenetic regulation of gene expression, epigenetic changes, so that those four are the crucial aspects that we need to remember from neuroplasticity. They're all under influence from you. You can actively engage neuroplasticity to do what? Through self-reflection and teaching others in this disciplined way, where teaching is not about punishment, but about connecting and integrating and allowing ourselves to impart anything we have to others, because, you know, as we've said in other journals, we're all a part of a similar system. And we embrace that. Yes, you can enjoy the me, honor the we, and have this identity as the we, as we've said. Now, what does all that mean? Well, I do a daily practice, and as I'm getting ready to move from this office, I've been doing a lot of reflection, a lot of thinking, and, you know, what's life have to offer? You know, here I am at this stage of my life. I've been here for almost 3 decades in this one building. I've never had a private practice outside of this building, so this building has a lot of meaning for me. I just have to let that really filter through my thoughts, allow it to be in my dreams. So this morning I woke up kind of sad, and I realized this is the last Monday that I'll be in this building, and what does that mean as time marches forward? All we have is the present moment. If we connect with each other with that kind of presence, that's the discipline part of this. If we connect with ourselves with self-reflection, that's this openness, we have this opportunity to cultivate integration within and integration between. Ultimately, that integration is what we can use neuroplasticity to create. Because this is the exciting moment we're at in our whole culture. You can use your self-understanding to create more compassion and kindness toward yourself. If things are tough, you can actually change the different connections in the brain, as in next year's journals we'll talk about. You can actually significantly alter the way your whole inner system works. We've now laid down the groundwork for how to do that. In terms of with other people, you can actually harness your own presence to inspire people to rewire their brains. How? Toward integration. And because, as we've said, integration made visible is kindness and compassion toward yourself and others, and kindness is honoring and supporting one another's vulnerability, it gives you a deep way of taking a breath and saying, as we go through all the transitions of life, births, evolution, development, death, everything we go through together, that together we can make this an integrated life. So thank you so much for being on this journey with me through the digital journal. I hope you've enjoyed the experiences we've had together, and I look forward to our future connections. Thanks a lot, and be well.